Hello everyone, and welcome back to our math session. Today, we are going to explore a fascinating category of word problems known as sum multiple problems. The concept here is quite straightforward but very powerful. We are looking at situations where we know the total sum of a group of items, and we also know that there is a multiplicative relationship between them. For instance, one number might be 3 times bigger than another, or perhaps there is a specific ratio between two groups. The secret to solving these problems isn't about memorizing complex formulas. It's about using logical reasoning to find shares or parts. If you can identify the smallest unit or share, you can express everything else in terms of that unit, add them up to match the total, and solving becomes simple arithmetic. To show you exactly how this works, we are going to walk through 5 different examples, ranging from school clubs to fruit harvests. Let's start with a scenario involving a school's calligraphy and dance groups. We know that together, these two groups have a total of 54 students. Now, here is the twist. We are told that if 6 more students were to join the calligraphy group, and 6 students were to leave the dance group, then the calligraphy group would be exactly twice the size of the dance group. Our goal is to figure out the original number of students in each group. Think about the total number of students first. If 6 people join and 6 people leave, the total remains unchanged at 54. In this hypothetical new situation, the calligraphy group is double the size of the dance group. So, if we imagine the dance group as 1 share, the calligraphy group represents 2 shares. Together, that makes 3 shares in total. If we take our total of 54 and divide it by 3, we get 18. This means that in our hypothetical scenario, the dance group has 18 students. However, we need the original numbers. Since the dance group dropped to 18 after losing 6 students, they must have started with 24. And since the calligraphy group ended up with 36 after gaining 6, they must have started with 30. So, originally, there were 30 students in calligraphy and 24 in dance. Now, let's apply this same logic to a different puzzle involving weights. Imagine 6 students weigh themselves, and their results are 32, 35, 37, 46, 47, and 49 kilograms. 2 of these students are from Class 1, and the other 4 are from Class 2. We are given a clue that the total weight of the 4 students from Class 2 is exactly double the total weight of the 2 students from Class 1. We need to identify which 2 students belong to Class 1. First, let's sum up all 6 weights. If you add 32, 35, 37, 46, 47, and 49, you get a grand total of 246 kilograms. Now, think in shares again. If the weight of Class 1 is 1 share, and Class 2 is double that, then Class 2 is 2 shares. Together, the whole group represents 3 shares. Dividing the grand total of 246 by 3 gives us 82. This tells us that the single share, the total weight of Class 1, must be exactly 82 kilograms. Now we just look at our list of weights and find a pair that adds up to 82. A quick check reveals that 35 plus 47 equals 82. Therefore, the students from Class 1 are the ones weighing 35 and 47 kilograms. Moving on to our third example, let's look at a farming problem. A farmer harvests apples, pears, and oranges, with a total harvest weighing 210 tons. We have 2 clues. The pear harvest is 20 tons more than the apple harvest, and the orange harvest is exactly 3 times the size of the apple harvest. Since everything is compared to the apples, we will treat the apple harvest as our base unit, or 1 share. So, we have 1 share for the apples. The oranges are 3 times that, so they are 3 shares. The pears are 1 share plus an extra 20 tons. If we combine all of these, we have 5 shares in total, plus that extra 20 tons. We know this equals 210 tons. To isolate the shares, we first subtract the extra 20 tons from 210, leaving us with 190. Now, we know that 5 shares equal 190. Dividing 190 by 5 gives us 38. So, the apple harvest is 38 tons. From there, it's easy to find the rest. The oranges are 3 times 38, which is 114 tons, and the pears are 38 plus 20, which is 58 tons. Let's try a fourth problem that deals with a chain of numbers. Suppose we have 3 numbers, A, B, and C, and they add up to 392. The relationship is strictly multiplicative. A divided by B is 2, and B divided by C is also 2. This means B is double the size of C, and A is double the size of B. We always want to start with the smallest number to avoid fractions, so let's say C is 1 share. Since B is twice as big, B is 2 shares. Since A is twice as big as B, A is 4 shares. If we add those up, 1 plus 2 plus 4, we get a total of 7 shares. We take our total sum of 392 and divide it by 7, which gives us 56. That means the smallest number, C, is 56. B is twice that, or 112, and A is twice B, which is 224. Finally, let's tackle a slightly more complex one involving fruit boxes labeled A, B, and C. The total weight is 1,611 kilograms. Here are the relationships. Box A is 12 kilograms less than 3 times box B, and box C is 15 kilograms more than twice box B. Just like before, everything relates to box B, so box B is our single share. Let's tally up our shares of B. We have 1 share for box B itself. Box A contributes 3 shares, and box C contributes 2 shares. That is a total of 6 shares. Now look at the loose numbers. Box A has A, minus 12, and box C has A, plus 15. Combined, 15 minus 12 gives us a net addition of 3 kilograms. So, our logic tells us that 6 shares plus 3 kilograms equals the total of 1,611. We subtract that extra 3 to get 1,608. Dividing that by 6 gives us 268. So, box B weighs 268 kilograms. From there, we calculate box A is 3 times that amount minus 12, giving us 792, and box C as 2 times that amount plus 15, giving us 551. As you can see from these 5 examples, whether we are dealing with people, weights, or abstract numbers, the strategy remains consistent. Identify the smallest unit or share, express all other quantities in terms of that share, and adjust for any fixed numbers. Once you equate that to the total sum, the rest is just simple calculation. I hope this helps you visualize how to break down these sum multiple problems. Thanks for listening, and happy solving!